If you survived all that information from the first two videos, here we are doing video number 3 called periodic table. Sorry, it's a lot of information this week that I have jammed into these videos. Okay, so we're going to talk about the periodic table today. Each element, okay, so we talked all about elements and the atoms and the properties of elements. So each element has these important characteristics. They have an atomic weight, they have an atomic mass, which we know are they're related and has to do with isotopes and the percentage of each isotope in the environment. Another physical property of an atom is its atomic number and its chemical symbol and the chemical and physical properties of that specific element. So for example, carbon. We know, so here we have an element card or symbol for carbon. And this is what you'll see on a periodic table. We have the C, that's the symbol for carbon. We have the name underneath. At the top, you'll have the atomic number. And what's the atomic number? Does anybody remember? Right. The atomic number is the amount of protons for this particular element. So for carbon, it has 6 protons. Now at the bottom, you have another number, and that is the atomic mass, or the atomic mass number, or sometimes the atomic weight. Now you see, this is not a rounded number. This is not a whole number because carbon also has isotopes. So it obviously exists in other forms where it has added neutrons to it. That's where you would hear about carbon-14 and things like that. Because really, you would expect if it has 6 protons in the nucleus, that it would also have 6 neutrons. But because there are other isotopes, we have to have an average here. It gives us an idea of how many of the other isotopes exist. Most elements were known and had been discovered by the late 1800s. The periodic table was established itself by 1869. And this man, this Russian chemist, Dmitry Mendeleev, he was the first guy to try to organize all the elements into a table. And he did actually a pretty good job. I think he was organizing them based on atomic mass number instead of maybe atomic number. So this periodic table is a way to order and arrange all the elements that we know of, all the ones that occur naturally, and also including the ones that were man-made. And they are arranged according to the elements and atomic numbers. That's how the periodic table is made up. Elements also are arranged by their properties, giving the table its odd shape. So if you're familiar with the periodic table, it does have an odd shape to it, which we'll see. The periodic table represents the periodic law of chemistry. And this is the periodic law of chemistry. It states that elements with similar properties occur at regular intervals called periods. So they're grouped by their properties into periods and also into groupings. The periodic table has 7 rows of elements, and these are called the periods. And so there are 1 through 7 rows. Each row represents the number of outer shells of electrons that are present for the elements in that period. Okay, so here we have the periodic table, and you'll see on the left-hand side, it says period, and the rows are numbered from 1 to 7. So it doesn't go any higher than 7. Each row or period has 1 shell. Each period represents 1 shell of electrons. That's where the electrons are known to orbit. Period 7 has 7 shells. And this means that the greatest number of possible shells for any electron is 7. There aren't any more shells. There's no electron that has 8 shells or 11 shells or anything like that. Okay, so here we have an example of lithium. Lithium it belongs in period 2, and it has 2 shells, okay? So lithium, you'll see, is found right here, period 2, and it's also on the far left-hand side because, and we'll discover that lithium has 1 electron in its outermost shell. Then we have an example of krypton, and krypton has 4 orbiting shells of electrons. Krypton is on the other side of the periodic table. It's actually known as one of the noble gases. And so what that means is its outer shell, that 4th shell, is filled with electrons. So it's very stable. If you know anything about the noble gases, they're known as very stable. They're very non-reactive with other elements. Okay, and then we have, this is radium. Again, it is found on the left-hand side of the periodic table, and it's in period 7, but it's in the second grouping. And so it has 7 shells of orbiting electrons, and if you look at the 7th shell, you'll see at the very top, it has 2 electrons in that outer shell. So some elements have only 1 electron in the outer shell, and they are grouped together. Some elements have the maximum number of electrons in the outer shell, and they are grouped together. The number of electrons also represents how reactive an element is, or how interested that element is in getting together with another element. So when I talked about the noble gases, we showed krypton, and we know that its outer shell was full. It had the most electrons that shell could hold. And so it's not reactive. It doesn't want to give up an electron or add an electron and then join together with another element. It's very happy and stable on its own. But on the left-hand side, in the group 1 and group 2 of the electrons, these ones are actually very reactive because they either have 1 electron in their outer shell or they have 2 electrons in their outer shell. And so they most likely want to give away their electrons so that they can then be very stable, because then their outer shell, what's left, is very stable. So elements are also arranged into groups. So we know that we have the periods, which are the rows 1 through 7, and then we have all the groups which go across this way. And the grouping can be labeled in numbers. I think most of the time it's done that way. Sometimes it's labeled with Roman numerals and letters. So either way. So the elements are also arranged in the groups, and the groups are labeled, as I said, either by Roman numerals and letters or just by numbers, and they go across the table, and they are grouped according to similar properties. For example, the metals occur on the left-hand side. All the metals, so we have the alkali metals and the alkaline earth metals, and all the blue ones are the transition metals, and then we have other metals here and metalloids. Metalloids means they're kind of in between. So we know that on one side of the table, on the left-hand side of the table, you have the groups and the periods of the elements that are highly reactive, and on the right side, you have the elements that are very stable. Their outer shells are full of their electrons, and so they they're very unreactive. They don't react with other things because they don't need to seek a more stable form. So that's it for video 3. And we will continue next week, and we're going to learn more about molecules and compounds and those kind of things. So if you have any questions, please feel free to contact me. I'm happy to help you in any way that I can. Have a great week.